Metals are reactive elements. They lose electrons to form positively charged ions. Thus, they are called electropositive elements. Let us perform an activity using some samples of metals to understand what happens when metals are burnt in air. Activity: take a copper wire, an aluminium wire, a magnesium ribbon, a piece of sodium metal, an iron wire, a zinc granule, and a piece of lead metal. Now let us heat all the metals one by one. Let us begin with a copper wire. Hold a copper wire with a pair of tongs at the top of the flame of the burner. What do you observe? Copper does not burn in air even on strong heating. On prolonged heating, we see formation of a black layer of copper oxide formed over the wire. Next, heat an aluminium wire. What do we see? Aluminium wire burns in air. There is also a white layer formed over the wire. This layer is formed due to the formation of aluminium oxide. Now, heat the magnesium ribbon. The magnesium ribbon burns vigorously in air, producing a bright light, and a white powder is also formed. The white powder formed is of magnesium oxide. Next is sodium metal. You must have observed that sodium is stored in kerosene. It reacts with oxygen even at room temperature and catches fire because sodium is highly reactive. Hence, sodium has to be handled carefully. Let us heat the sodium metal carefully. Sodium metal burns violently with a bright yellow flame. When it is heated for a long time, we see formation of a white powder. This is due to the formation of sodium oxide. Now let us heat an iron wire. What do you observe? Iron glows with a bright yellow-orange color. On strong heating, it gives out sparks. Now take a zinc granule and hold it in the flame. Zinc burns with a bright light. A white powder of zinc oxide is also produced. Now heat a small piece of lead metal. When lead is heated strongly, it burns with a white flame and a white powder of lead oxide is produced. Reactions of metals. Reaction of metals with oxygen. We have seen that most metals react with oxygen to form metal oxides. Only their reactivities differ. Sodium and potassium are highly reactive metals. They react with oxygen even at room temperature. Sodium reacts with oxygen to form sodium oxide. Potassium also reacts with oxygen to form potassium oxide. Sodium reacts with oxygen even at room temperature and catches fire. Therefore, sodium is stored in kerosene to prevent its reaction with oxygen, moisture, and carbon dioxide in air. Oxides of some metals are soluble in water. They react with water to form alkalis. Sodium oxide dissolves in water to form the alkali sodium hydroxide. We have seen that a magnesium wire burns vigorously in air to form magnesium oxide. Magnesium oxide reacts with water to form the alkali magnesium hydroxide. Reaction of metals with water. Take samples of calcium, aluminium, iron, and zinc. We shall now carefully add each of these metals separately in cold water and observe the reactions. Calcium reacts with water less vigorously, producing bubbles of a gas which stick to the surface of the metal. This causes the metal to float in the water. Calcium forms calcium hydroxide and hydrogen gas is evolved. The heat evolved in this reaction is not sufficient for the hydrogen gas to catch fire. Now let us check what happens when an iron nail, a piece of zinc metal, and an aluminium wire is put in cold water. What do you see? Iron, zinc, and aluminium do not react with cold water. Now let us see whether these metals, that is, iron, zinc, and aluminium, react with hot water. Iron, zinc, and aluminium do not react with hot water. How would sodium metal react with water? Sodium metal reacts vigorously with water, producing sodium hydroxide and hydrogen gas. The hydrogen gas evolved catches fire. A lot of heat is produced, hence it is an exothermic reaction. Another metal which can produce a similar reaction is potassium. Potassium reacts vigorously with water, producing potassium hydroxide and hydrogen gas. We have seen that iron, aluminium, and zinc do not react with cold or hot water. Do these metals react with steam? To find out, let us perform an experiment using the metal iron. In a boiling tube, place a piece of glass wool soaked in water at the base of the tube. Place the piece of iron in the middle of the boiling tube. On heating the boiling tube, water gets converted to steam, which reacts with iron to form iron oxide and hydrogen gas. Hydrogen gas comes out of the boiling tube and is collected over water in a glass jar. This experiment shows that iron reacts with steam. Similarly, aluminium and zinc also react with steam to form the corresponding metal oxide and hydrogen gas. Aluminium forms aluminium oxide and hydrogen gas, while zinc forms zinc oxide and hydrogen gas. Metals like copper, gold, and silver do not react with cold or hot water or even with steam. Now, let us summarize the reactivities of the metals with water. The metals sodium and potassium react violently with cold water to form alkaline hydroxides and hydrogen gas. The reactivity of metals with water is less for calcium. The metals aluminium, zinc, and iron do not react with cold water as well as hot water. They react only with steam to form the metal oxide and hydrogen gas. The metals gold, silver, and copper do not react with cold water, hot water, or even steam. We know that metals react with acids. Are all metals equally reactive? Let us perform an activity to understand this. Reaction of metals with acids. Activity. Take some zinc granules in a test tube. Add a few drops of dilute hydrochloric acid to it. We will observe formation of the gas bubbles on the surface of zinc granules. Fix a bent tube and allow the gas being formed to pass through the soap solution taken in a trough. What do you see? We can see gas-filled bubbles formed in the soap solution which rise in the air. Now let us bring a burning candle near a gas-filled soap bubble. The gas present in the soap bubble burns with a pop sound. Hydrogen gas burns, making a pop sound. Zinc reacts with dilute hydrochloric acid to form zinc chloride and hydrogen gas. Similarly, magnesium, aluminium, and iron also react with dilute hydrochloric acid to form the corresponding metal chloride and hydrogen gas. Let us see the reactions. Magnesium reacts rapidly with dilute hydrochloric acid to form magnesium chloride and hydrogen gas. Aluminium reacts slowly with dilute hydrochloric acid compared to magnesium to form aluminium chloride and hydrogen gas. We have seen the reaction between zinc and dilute hydrochloric acid. It is less rapid than the reaction of aluminium with dilute hydrochloric acid. Iron reacts very slowly with dilute hydrochloric acid to form iron chloride and hydrogen gas. Is the rate of formation of bubbles the same in all the test tubes? No, it is not the same. In the test tube containing magnesium, the rate of bubbling is fast, followed by aluminium, then zinc, and the last is iron. So we can say that magnesium is more reactive than aluminium, followed by zinc and then iron. These metals would also react with sulfuric acid in a similar manner to give hydrogen gas. How do these metals react with dilute nitric acid? Reaction of metals with nitric acid. When a metal reacts with dilute nitric acid, hydrogen gas is not evolved. This is because nitric acid, being a strong oxidizing agent, oxidizes the hydrogen produced into water, and nitric acid itself gets reduced to any of the nitrogen oxides, that is, dinitrogen monoxide, nitrogen monoxide, or nitrogen dioxide. For example, copper reacts with dilute nitric acid to give copper nitrate, water, and nitric oxide. Copper reacts with cold and concentrated nitric acid to give copper nitrate, water, and nitrogen dioxide. We know that gold and platinum do not react with water or any acids. They can be dissolved in a highly corrosive and fuming liquid called aqua regia. Aqua regia is a freshly prepared mixture of 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid, the ratio being 3:1. Let us now perform an activity to understand how metals react with solutions of other metal salts. Reaction of metals with salts of other metals. Activity. Take solutions of copper sulfate and ferrous sulfate in 2 test tubes. Put a clean iron nail in the solution of copper sulfate and a clean copper wire in the solution of ferrous sulfate. Do you find any change in the iron nail? The iron nail gets coated with a reddish-brown color, and the blue color of the copper sulfate solution has faded. What must be the reaction? Iron displaces copper from copper sulfate solution to form iron sulfate and copper. It is this copper which gets coated on the iron nail. This is a displacement reaction. In the second test tube, is there any change in the copper wire? No, there is no change in the copper wire. We have seen that reactivity of all metals is not the same. But all metals do not react with oxygen, water, or acid. Hence, these reagents are not useful to determine the relative reactivities of metals. From the displacement reactions of metals with solutions of salts of other metals, the reactivity of metals can be understood. If a metal A displaces a less reactive metal B from the salt solution, it means that metal A is more reactive than metal B. In the above activity, which metal is more reactive? Copper or iron? You are right. Since iron displaces copper from copper sulfate, it means that metallic iron is more reactive than metallic copper. From all the activities that we have discussed so far, we can conclude that the reactivity of metals differ from metal to metal. Scientists performed many experiments of displacement reactions and developed the reactivity series. Metals can be arranged in the order of their increasing or decreasing reactivity. Such an arrangement is called the reactivity series of metals. Metals are divided into groups according to their reactivity. Highly reactive metals, moderately reactive metals, and less reactive metals. Let us now understand how metals react with nonmetals. Reaction of metals with nonmetals. We know that noble gases like helium, neon, and argon have a complete valence shell, hence they are chemically inert. Therefore, they do not take part in a chemical reaction. The reactivity of elements depends upon the tendency of an atom to attain the electronic configuration of the nearest noble gas with complete octet. Metals attain a stable electronic configuration by losing electrons, while nonmetals do so by gaining electrons. We have learnt in the previous classes that the ionic compound sodium chloride is formed when sodium metal gives away one electron while the nonmetal chlorine takes up one electron. In the same way, magnesium forms the ionic compound magnesium chloride and potassium forms potassium chloride. Let us now discuss the chemical properties of nonmetals.